Today is October 7, 2024, and we are talking about clock sequential logic. These are the books I am following. One is Maurice Mano, same 5th edition, and now we are going to have these topics, and I am also following this particular book, which has just one author, Maurice Mano. It has little bit different content, so I like it, so I kept it here for the teaching purpose. This book came in 2016. Okay, so let's go and let's write it down, the excitation table. So somebody can help me in that. What was the excitation table for qt plus 1 with set and reset? What was that? Can you tell me? Look at your notebook and tell me. So 0 0, 1 don't care, okay. 0 1, 0 1. So 1 0, you mean to say. Don't care 1, then this is 0 1, 1 0, this has to be 0 1, and this is 1 don't care, right? Okay. By the way, this is with the assumption that we are using NAND gate based SR gate, SR latch, then this is going to happen. Otherwise, in other condition, it will be different, right? What about JK? What about this one? 0 don't care, 1 don't care 1, and don't care 0, right? Okay, so D and T are quite easy, so like it's very simple, just for the repetition part. So it will be as it is, like next state, right? Okay. Okay. Is there anybody who has who feels that this is going fast? Like last time 3 girls made me. Please let me know where I am fast so that I can explain that again. There were 3 girls last time, I forgot. Yeah. No, not Charmi, right? Okay. Okay. So pace is fine or not? Because like in last feedback also 90% people were saying it's fast. That's why I'm asking. If it is fast, like you need to ask me where it is like fast, or if you don't understand something, I can understand you are working from it's like from morning 8 to evening 8, right? You have your lecture, so your efficiency is also going down. I can see that. But in case I can do my job, I can explain something. If you want, I can explain it again. Okay. Any doubt in this one? Those who are sitting here, any doubt in this one? Okay. Just for, okay, Urjit and Dhruvesh, you can also note down that October 14 is going to be, I'll send you one assignment, right? So, assignment 3 exam will be there. So, it's full. So, on October 14, I am out of Ahmedabad. So, this can be done. October 19, I am not here again. So, Saturday lecture will not happen. Okay. And then I'll come back exactly on October 21 morning I am coming. So, we'll have lecture on October 21 after this, right? This Friday and everything will be as it is, just these are the things. October 19, no lecture. Okay. That Saturday, no lecture. Okay. So, we'll try to compensate maybe on some Wednesday or whenever it's possible, when we all agree, right? Okay. So this is the thing. I'll send you by tomorrow or day after tomorrow. Those questions will be very easy based on what we are going to study today. Okay. So let's start from here. Actually we want to find out, Radha, and so actually we want to find out this circuit, this is our actually requirement. So if you remember the first time when we talked about two things, synthesizing and analysis. So if the circuit is given to me, I am going to analyze it, but actually I'll not have the circuit. I have to find out the circuit. This will be the actually my requirement. Right now, just for starting, we are starting with the toy question. That question is, if the circuit is given to you, let's find out what will be coming at the end. Actually, whatever coming at the end, that will be the question for the further topics. So that will be the requirement from our side. So let's look at that. So X here is an input. X here is an input. You can see here there are two flip-flops are there. So two flip-flops are there, D flip-flop, right? And there is a clock. Clock is connected to both the flip-flops simultaneously. So this is a synchronous circuit, first of all, right? Second thing is, as there is no bubble, this is a positive age triggered clock, right? Whenever clock is going from 0 to 1, that's the meaning of that. Whenever it's going from 0 to 1, I should get the answer or whatever is available at the D. So if D is available with something like this, let's say if this is a D input, then what I am going to see, if it is a flip-flop, I am going to see the output as, so this is the clock and this is Q. Here it will be 0 only, and next time again when it's coming here, it's 0. The reason is it's going to give you the answer only at this transition. Whatever is there, it's going to be latched, as we have studied in previous lecture, and this is the ideal situation. However, we have to take care of two things. We have to take care of setup time and hold time. Setup time is the one which says that the signal has to be available before the clock reaches over there. So before clock reaches over here, you have to have some time before that the D input is available as 0 or 1, or at the same time same input has to be hold for some more time, right? If it is changing, then it will violate many things and maybe it will give you the wrong answer. So these are the known as timing constraint. We have to take care of it. In case it is like this, if it is like this and it is well within the given setup time and hold time of the flip-flop, then the output of this one will look like this one, because at this time it's D equal to 1. So D equal to 1 will be latched and that will be given to the output after some delay. I am drawing it exactly on the same edge. However, in reality the output will look like this one after some delay, of this clock, right? But whatever was available here, that will be reflected over here, right, after some time. So after the settled output, after the the available worst case propagation delay, you need to check that. So that is over here. Okay. So any doubt in this setup time, hold time? Okay. So let's go further. So let's assume that everything is fine, setup time, hold time wise, and whatever D input is coming, that will be given to the output A and output B. By the way, these two flip-flops can give me how many number of states are possible? If there are two flip-flops, how many number of states are possible? 4 states are possible, right? So they will be 0, 0, 0, 1, 1, 0 and 1, 1, right? Because of A and B of combination, you will have 4 states, right? A and B are the one which will be treated as Q and Q bar. Here in the example, it has been taken as A and B. However, they are Q and Q bar only. Just to identify that they are the outputs, they made it A and A prime. This is from again 5th edition, the same book, this book only. This is taken from this book only. Okay. Right. Some books are also writing QA, QA bar and then QB and QB bar. That's also possible, but here you can read them as outputs, right? Now what we need to do, we need to analyze this circuit, that we have to write down the next state in terms of present and inputs. There is one more thing, y is actually output. So output has to be written in terms of next state and input, because it's a function of input x over here, right? So we can write down that. If we are writing that, what will be the equation for a t plus 1? Understand one thing, that t plus 1 is the next state, and same a is going over here, which is acting here as a of t, right? Then and then after some propagation delay of time on the critical path, a t plus 1 will be available. But at a time t equal to 0, a of t is coming here. Let's say if it is 0, then 0 is coming here, and after some times if it has to be changed, then it requires some time to become a t plus 1. Is it okay, or you understand or no? Any doubt this side? Okay. So if that is the case, can we write down the equation for this one? So a t plus 1 is equal to what? Here we can write down that a of t times x plus b of t times x. Is it okay? Right? Or you can write down x is common, a of t plus b of t, right? That's equal to a t plus 1. Same way we can write down b t plus 1, and b t plus 1 is equal to what? It's going to be equal to, so this is coming here, this is for y. It's only two things, it's a prime and x, right? Right? So same way we can write down y, right? So these are the combinational logic. I'm not going into solving that. Let's look at the direct answer. So this is one thing which we have written, a t plus 1 equal to a of t times x of t plus b of t times x of t, a prime t x of t. For a time being, you can drop these t. Okay, that's possible, right? We can drop and you can call them as ax plus bx. A will be treated as a of t only. So we are dropping the time, but both are synonym to each other. Just for writing purpose, we are doing this. Same way we can write down y of t, which is y equal to a or b times x prime, which is coming from there. Now I have these two equations. Look at this. What was the equation? So these two equations are there, which are telling me that these are the present state and these are the next states. So what I am supposed to make is as follows. I have to write down a of t, b of t, which are present states, and based on the input, I need to write down the next state, which is a t plus 1, b t plus 1. So there are combinations. So there are 3 inputs now, a, b and x. So we will have 8 combinations, right? So I am writing few of them only, whichever is. Okay. Right? Whatever it is, don't worry. So here this is 1 0 1 0 1 0 1 0 1 0. So let's look at the first one. What will the AT plus 1 for the first row? Looking into this equation, 0, and what about BT plus 1? 0, okay. What about this one? Okay. So feed such values, you should see something like this. So this is next state, which is written in terms of, this equation, AT plus 1 is equal to AX plus BX, and BT plus 1 is equal to A prime X, right? And same way Y was also some function. From there only we have found out this. Is it okay? Okay, we are taking build up, look. So please keep this thing in your mind, right? And you can little bit second form of state table, where you can little bit make it easy to read with less number of rows but more number of columns. You have incorporated x equal to 0 and x equal to 1 inside the next state itself, right? Through that you can write down this. As we know that only there are 2 flip-flops were used, so there will be 4 states which are visible over here, right? Now I am going to make one diagram. Just look at that diagram carefully, because that diagram is very, very useful, right? So now 4 states are there. One is 0 0, 0 1, 1 1, 1 0. What we are doing is like you are going to study in automata theory whenever you are going to study in future in the discrete mathematics. It's also the first chapter of finite state machine or FSM. So we are into that. So if the first state, which is 0 0, look at this 0 0. If so, we have to read as follows. Whatever state is there, actually on the same place you are going to have the next state also, and at the same place you will have the present state also. So there are 2 arrows are required. So if I am writing this is state 1 and this is state 2, state 1 to state 2 will be there if there is certain input I am applying, and whatever will be the output I am going to write down with oblique. This is the notation. Between 2 states there is a transition when input is whatever value we are going to write it here, or whatever value we are going to write it down here as output. As an example, if there is a state 0 0 and there is a state called 0 1, if I am writing like this, it means that the present state is 0 0, next state is 0 1, when I am going to apply input of 0 and at the same time output will be 1. Are you able to see this? So there are 2 states, present state, so it's you have to read the arrow, whatever the arrow is moving and wherever it's pointing, that becomes the next state, right? Now let's say if this is the case, can you read and tell me what will be the meaning of this one? The green part. Can you read this, Vedant? So what is the present state here? Present state is 0 0, next state is 1, sorry, next state is same 0 0 if input is x, input is 1 and at the same time output equal to 0, right? You can read this, right? So let's draw that here. We have 4 states are available. X equal to 0, that's input. Okay. Tell me. We can write down 0 0, but 0 is already used, right? X has only 2 possibility. X is input. So as per the format, it's input oblique output. That's the international, standard, right? In finite state machine, this is the only way to write down that input oblique output. So there are only 2 possibility. Either it will be 0 or 1. If it is 0, it's only going this side, right, or depending on your circuit.
Sir, but for when the input is 0, the output is also 0 for the second.
You can assume anything. I assume something and I kept it here. That is also possible. For a given input, output may be both time it might be 0. But input is only like 0 or 1. Right? There is no third possibility here in this case. When we are going to make this, maybe you will understand. So, read the first row, what it says Vidhan. Present state is 0, 0, next state is again 0, 0. When input x equal to 0 and y equal to what? 0, right. So, we have following informations: present state, next state, input and output, right. Can I draw like this? The first row has been transformed into diagram like this. Let us go to the next one where it is 0, 1, right. So, when it is 0, 1 here, 0, 1, next state is 0, 0, right, and sorry 0, 0, when next state is, okay, let us take this one also, right. So, 0, 0, next state is going to be equal to 0, 1. So, it will be going here 1 oblique 0, okay. Okay, so 0, 1. Now, next is 0, 1. So, where it should go? When x equal to 0, then it should go back to 0, 0. And at that time, output is equal to 1. So, note that very carefully. So, if it is 0, 0, 0, 0 and this is 1. Is it okay? Present state is 0, 1, next state is 0, 0, input is 0 and output is 1. Is it okay? Now, let us draw the next one. If 0, 1, next state is 1, 1, right, when x equal to 1 and y equal to 0. So, 0, 1, it will go to 1, 1, when input is 1 and output equal to 0, right. At the output of each state, there are only two possibilities because we have only one input. So, either it can be 0 or 1. If there are multiple inputs, let us say if there are two inputs, let us call that, or let us call those input as something alpha and beta, two inputs are there, then there are possibility of 4, 0, 0, 0, 1, 1, 0, 1, 1. But in the case of only one, we will have only two possibilities, 0 and 1. We will have one example where we are going to have two variables also as an input. So, what will happen if input is 1, 0, present state is 1, 0, next state is 0, 0, 1, 0, 2, 0, 0, when x equal to 0 and y equal to 1. Same way, 1, 0 become 1, 0 when x equal to 1 and output is 0. Same way, if it is 1, 1, next state is 0, 0, 0 and this is 1, and in the case of x equal to 1, that will go to the 1, 0, 1 oblique 0, right. By the way, as time progresses, you will see that we need to draw finite state machine first and then you have to derive other things. Our agenda is to find out this circuit, okay. When as time progresses, you need to find out this circuit, Okay, we are doing it reverse right now, right? Right now we do not know what this circuit is doing, but maybe in future we'll know that. Okay, this is for just for understanding. So, okay, so this is same thing. So what we are doing in summary, the steps are as follows. That circuit diagram is available with you when you are doing the analysis. Write down the equations, write down the state table and draw the state diagram. This is what we did. Okay. The important thing is there is no difference between using state table and state diagram. The only thing is state diagram is actually very easy to look at that and to evaluate it. And when we are going to feed the information in terms of flip-flops, it will be much more easier. So that's why we are doing it. And let's see how it will be if it is going from other circuit. So if the equations are available, then again my agenda is to draw the state diagram, but let's see how it goes. If these equations are given to me, it has only one flip-flop. Can you see? Only one flip-flop. Are you able to see only one flip-flop, right? It's only DA, and there will be clock. Do not forget to keep this clock, because that is the one which is running the whole system. What it says, it has three things. Right? So this is the circuit for that one, right? A XOR X XOR Y, that's the next state, and that's what actually you are saying. What is at the input DA side and what is at AT plus 1, right? So that's the circuit diagram. Now the next thing is you need to write down the state table. Can we write down the state table? Present state, you please write down. Present state, I need following. Present state, next state, present state is AT, next is AT plus 1, when x equal to 0 and x equal to 1, and what is the output? That we need to write down. Actually, you need to keep three possibilities, sorry. You need to keep y also. So you need to write down 8 possible rows for both of them, A, X and Y. And for that, you can write down AT plus 1. So AT plus 1, so X and this is Y. So what will be the first answer? It's 0 because it's an addition. This is 1, 1, 0, 1, 0, 1, 1, right? Something like this. Based on this, can we write down, can we draw the state table? Note that we have only one flip-flop. So how many possible states will be there? Only 2, right? And what are those states? 0 and 1 only. Am I going fast or we follow till now?
In the last second, the answer will be 0. 1, 1, 0.
Right. This is fine? No issue. Okay. So there are only 2 possible states, 0 and 1, right? Note that in this circle, A is written actually, A of t and A of t plus 1 both are here, right? So if you are here, the next present state is 0, next state is 0, then input is in the presence of 0, what's happening? You just need to write down and you need to make the diagram, because here there are two possibilities are there. Okay, sorry. Here two possibilities are there, x and y. So, you need to write down accordingly. As I was mentioning last time, that when you have two inputs, so two inputs are giving you four possibilities. Only one flip flop will give you two states. So, two states are 0 and 1. Now, you need to feed the information. If the present state is 0, next state is 0 when inputs are 0, 0. Note that we do not have anything called output right now. In this circuit, there is no output. So, then you are not going to write down any output, right. Next thing is, if the present state is 0, next is 1, then the input is 0, 1. Same way, if the present is 0, next is 1, if the input is 1, 0, right. This you can write down. Oblique is actually kind of illegal because it is already used for the output, right. So, any of the inputs will be there. The transition between present to next will happen like this. Same way, 0, 0, it will be oblique 1, 1. So, you can write down all four states and you can, so there are various ways to make that, right, and you can make the whole thing over here like this, right. Is it okay till now? All fine? All fine? Okay. What's your name? Sakina. Okay. You met me last time that it is fast. Okay. So now it's going fine or no? Okay. You are like hidden behind this podium, so I could not see you. Okay. So now is it fine? Okay. Okay. With your permission, I am going further then. Okay. So if this is done, now let's go to the next one, which is very simpler again. So you need to do same thing. You need to make the table where following things are there. Look, there is only one input. Two flip flops means four states are there, right. So you just write down that. First of all, find out what is J and K. Now we need to write down J and K. What is the value of JA and KA, JB, KB and BT plus 1, AT plus 1. You just find out that. Can you do that or difficult? Do you understand? This is not D flip flop. So you can't say that AT plus 1 is equal to exact JA after some time. It's not going to happen. It is depending on other value also, and there you need excitation table. But you first write down the equations JA, KA, JB, KB and A of T plus 1, B of T plus 1. You just write down. Yeah, please. What happened? Now you require to do it in notebook. Okay, everybody has. Which okay, you are saying in the diagram. Okay. Okay. So sorry. Okay. So I'm keeping it to you people. You just copy this. You just copy this. Okay. This is the first question of your assignment. Okay. This is the first question of your assignment, assignment number 3, whose exam will be on October 14. Okay. So you have to draw the state diagram. Okay. Now, how to do it? I can tell you the process, right? Is there anyone who can tell me the process? It is not same as the D flip-flop. It is a little bit tricky. So, what is JA? Okay, let's go this way. JA is equal to J is equal to B T plus 1, sorry, B of T, because at that time it will not be T plus 1, it will be only B of T, right. J equal to B of T. What about Ka? X prime and B. Same way you can write down JB and KB, right. So you solve it. Now what you have to write down? You have to write down present state, A of x, B of x, and input, sorry, A of t, B of t, and the input x, right. After writing this input x, you are interested in next state. There is some problem. Okay. So next state is only possible with, what do you need for having the next state? You know the value of J and Ka, so you need to write down that. Before writing to the next state, you can only write down Ja, Ka, Jb, Kb, and then next state. Right? You can write down Ja, Ka, Jb, Kb, that is known to you already through the equations. You feed it over here. Then on the basis of present and J and K, can you write down the next state? If you remember, we did this exercise when we were doing the JK latch. Right? Is it okay? Vrushti, how to do it? Can you repeat that? No, this is fine. So, how to find out the next state? Because that is what you require, right? Here next state is not known to me. Why do you think next state is not available, by the way? Okay. Do you understand this?
We will not directly get the next state.
Why not? Actually, next state is depending on two things. Sorry, three things. Input to J, K, and as well as the present state. On the same line, how can you know that this is what will be the value of the present state? So you need to look at the state table, not the excitation table. So here for the given present state combination and through these equations which you found out here, J, K, JB, KB, you feed it over here, find out those values, on those values derive the next states. Right? So then you can find out that J, K, let us assume that J, K are 1, 1, 1 and A of t is equal to, let us say 0, 0, or let us make it 0, 1. So what will be the answer? Can you tell me? I am just assuming some case, okay. This might not be the correct one. I am just assuming one case. So if present states are 0 and 1 and J, K are 1, 1, what should be the next state in terms of A t plus 1 and B t plus 1? It has to be Q bar. If you remember, J, K both are equal, it has to be then inverting the present state, right. So it will be 1 and 0. If it is 0, 0 and if it is 0, 1 over here, same will go there, right? Same way, if this is 1 0, this is 0 1, right, and whatever values are here, it doesn't matter, because J is read as set and this is reset. So set means 1 and reset is 0, right? So sorry, you can write down only for A flip flop only, not the B one. For B you need another entries. For B you need another entries. It might be any other entries also, right? If it is like this, then it will be whatever the values are there, you have to write down that, right? So for the case of 1 1, this will be 0. For the case of 0 1, it's a reset. 1 0, it's set. 1 1, this will be inverted, right? So something like this, you have to feed that, and then once you have the present state and next state, you solve it on the basis of the input. So draw that. So you will have 4 states, A, B, C and D. 4 states will be there and you have to draw that. Okay. I am keeping to you people. In case if you need my help, just let me know in between. I will try to help you out. Okay. Okay. So is it same? Okay. So there is another one example where present state and next states are written. When there are present states of A and B, how many flip flops will be there? How many flip flops are required in this case? Only 2, right? Because 4 combinations will give you 2 flip flops. Note that there is no unique answer in terms of all these questions, because you can solve all these questions with different combination of present state and next state. Right now it's possible to, for this question you will get the unique answer. However, other questions it will not be the same thing, because sometimes present state might be just 5, let's say, then 3 are unused. Some people are choosing different 5 states, I might be choosing something different, then the answer might be different, right? Do you understand? So that way it's depending on what state you are choosing, right? So this is the question. So can we draw the state diagram for this one? Please draw that. The answer is already like there, it's not so much difficult, but so there are 4 states, 0 0, 0 1, 1 0 and 1 1. So Sakina is there. Okay, so tell me what will happen to this 0 0. So when x equal to 0, next state is equal to 0 0, and y equal to 0. So how to draw that? Same thing should I do like this? When x equal to 1, y equal to 0, next state is 0 1. So how to draw that? Right? Same way, 0 1 to 1 1, if x equal to 0 and y equal to 0, 0 1 to 0 1 when x equal to 1 and y equal to 0, 1 0 to 0 0 when the input is 0, output is 0, right? Then 1 0 to next state is, okay, here there is, I read that one as 0 1 to 0 1 only. So it's 1 and 0, right? 1 1, okay, that's the last one, but 1 0, 0 has 0, 1 sorry, 1 0 has 0, so this is the 1 0 with 1 input and 1 as output, so this is going here. 1 1 with 0 input, it's going 1 0 and 0 output, and 1 1 to 1 1, 1 1 and 0, right? Something like this, right? You can confirm that here. Okay. Any doubt in this one? Okay, it's about the careful, things you have to do. Okay, so now there is one more question. So we are going into another question where you can see 1, 2, 3, 4, 5, 6, 7. 7 states are there. So how many flip flops are required here? How many flip flops will require over here? It's very easy. Not 7. They only 3 are required, right? So in that case, one state will be unused. But before going into that, let's write down the present state and next state, the input and output. Please help me in writing down this. So present state is A and next state is A when input is 0 and output is 0. When input is 1, output is 0, next state is B, right? Now we are at B, so when present state is B, next state is C, when the input is 0, output is 0. When input is present state is B, next state is D, 1, 0, right? Let's go to C state. So C, next state is A, 0, 0, present state is C, next state is D, 1, 0, right? Present state is D, next state is E, 0, 0, D and F, 1, 1, and then F, next state is G, 0, 0, I am writing here, F, next state is F only, 1, 1, right? Then okay, G, so next state is A, 0, 0, G, next state is, where is 1, okay, F, 1, 1, you see? So you can write down E, okay. Okay, so same thing can be written in this way also, right? X equal to 0, X equal to 1, yeah. Last to last. अरे यार बहुत स्त्री 2 देखने के लिए स्त्री 1 देखना जरूरी है. Tell me what is the doubt. Sakina will explain. Sakina will explain. Can you please help me? Please help me. Can you please help me in this? What? It is playing with the same thing. Look, 0, 0. Just look at this 0, 0. Next state is 0. Look at this. Row and column you need to check. Let's look at the next. This one. Then it will be easier. Don't worry. Look, it's all about like you have to practice on your own. Then and then you can have the correct answer, right? So this is the summarized table. What we did it for this one, okay. Now let's observe some of the states. Please come back. Yeah. So observe the states. Some of the states are identical to each other, like G state has A and F. So just observe this. At the same time you need to look at the outputs also. Can you see? So G state and E states are identical to each other. I can call this one as E equal to or G equal to E. I can call G equal to E, right, wherever G is there, okay, that's all, right. Only one place G was there, so I kept it over here, right. So this is gone. I am trying to reduce the states now. Now look at other one. So this D state and F states look like same, right. Right. So now I can cancel this and make it as a D. Wherever F is there, I can call that one as D, right? Right. So this is the case. Is it okay? Any F is left? No, right? So this is also gone. Look, I can't change this AD because the outputs are 0 0 and 0 1 here, right? They are not identical. They are not identical. These two entries are not identical, right? I can reduce only to two states, right? Even though after reducing two states, still I need how many number of flip flops? 3 only, right? So now it's up to you that what you want to call A, B, C, D and E. You can call like that. You have 8 possibilities are there. So any of the 5 you can choose. Accordingly, the answer will change. Look, okay. So this is just for information. So this is same thing what we did. Okay. So here this is the reduced state table, which has only 5 states are there, and that you need to assume. This is, by the way, final answer. With the same thing, again it has been drawn. If you want, like for Vidhan, I am drawing it. Okay. So. Huh? Okay. Then you have to practice. Okay. If you know, then like there is no issue in that, right? Those who do not know, otherwise people will blame that I am going fast. Look. It's not only about you, okay. There are many more who are not able to speak, but yeah, they have same feeling. So, okay. So in this case, if present state is A, next state is A, and inputs and outputs are 0 0, right? Right. If present state is A, next state is B, when the input is 1 and output is 0. For the case of B, when x equal to 0, it goes to C with output equal to 0, B to D when 1/0, C to A when 0 0, C to D when 1 0, D to E when 0 0, D to D it's 1 1, E to A it's 0 0, and E to D it's 1 1, right? So something like this. Okay. Actually, the difficult part is to make this one. When we will have the question where you have to make this one without having anything, that will be difficult, right? Anyway, so if this is the case, then let's solve this, and we have to assume. So there are plenty of way to do that. You can choose different values of A, B, C, D, E. So the 3 possible assignments have been taken, right? Whichever you like, you can choose that, right? I think the book has followed. By the way, this book is the second one which I am following, solving the questions. It is the second book, okay, 2016 book, from where I have taken all the questions. Wherever you are seeing everything in black and white, that's the second book. If the questions are coming in blue color, right, they are with the 5th edition. Okay, this is just for your information. Okay, so now I am choosing, let's say, present state as like these possible combinations I have taken as A equal to something, B equal to something, C equal to something, D equal to something, and E equal to something. Accordingly, those things have been placed from this diagram, by the way. I have replaced with the value, this one as 0 0 1, 0 1 0, 0 1 1, 100 and 101. So 100 and 101. So I have to fill the table with the values given over here 001, 010, 011, 100, 101, right? And then I have to fill the whole table where what we did it earlier. So this is from there only, the whole table has been filled up, right? So when this is done, right, now in this case circuit was not available. Look at this, the circuit was not available. Actually we are going with the same thing what we need to do. So if some problem is given to you where you have to find out this state table with your assumption, we'll learn it with the some real time applications where we have to draw this one and we have to find out the circuit. So circuit is missing here. So how to find out the circuit? Let's look at that. So if this is the thing and I am using a D flip flop. So by the way, how many flip flops are required in this case? 3 flip flops, right? 3 flip flops, each will have name called A, B and C. Each will have one input DA, DB and DC, and at the same time each will have the output. You can call them as A, B and C. A, B and C acting as present state as well as next state with those combinations. Those are written over here. Same way we have to keep the clock simultaneously over here. Do not forget to keep this clock. If you do not keep the clock, then the whole system will not work, right? So for the synchronous design it has to be there always. Now I need to find out DA in terms of A and X, as well as I need to find out output Y. But before going to that, let's write down DA, DB and DC. Do we know that how to write down? Through the present state and the next state. Do we know that? How to find out DA, DB and DC from the present state? Vedang, do we know that? Do we know that some technique through which you can find out DA, DB and DC from the present state and the next state? Excitation table, right? Yeah, you can speak directly. Right? So what will the answer over here? So when x equal to 0 and x equal to 1, right? So x equal to 0, then this is exactly equal to, I can say that next state is equal to D, right? That is what we derived also, right? So this is also DA, DB and DC. This is also DA, DB and DC. Going fine? All this side going fine? Right? Because next state equal to D. Then I need to write down, or I need to find out DA in terms of present state and the input. I need to find out DA, let's start with DA, in terms of present state and and input. How to find out? Use K-map, right? Use K-map and solve that. Let's starting with DA. So you have 4 variables are there. So you have 16 possibilities. So let's call this one as, let's say, small a, b, c and x. Small a, b, c and x. Let's fill that. So 0, 0, 1, 0 is going to give you 0, 0, 1, 0. 0, 0, 1, 0 is going to give you output as 0, right? Because next state is equal to actually the value, right? Okay. Now going with the next one, 0, 1, 0, 0, 0, 0, 1, 0. 0 0. Okay, I made mistakes in, it's same only, right? Sorry, 0 0 1 1, it has to be 0 0 1 1, I have to take care of this, sorry. So in that case it will be 0. Now look at this, 0 1 0 0 0 1 0 0 0 0 1 0 1 1 0 1 0, sorry, 0 1 1 0 0 0 1 1 0 0 0 1 1 1 0 1 1 1 1 1 double 0 1 double 0, then 0 is 1 1 0 0 1 1 1 0 1 1 0 1 0 1 0 1 0, it's 0 1 0 1 1, it's 1. Rest of the places you are going to have don't care condition because you don't have all 16. 0 0 1 1, sorry. So 0 0 1 1 is 0. Look at this, I follow this way. So first entry is 0 0 1 0 0 0 1 0, and this is the DA entry, right? So this 0 has been kept over here. 0 0 1 1, so 0 0 1 1, 0 has been taken from there, right? Again 0 1 0 0, so second entry 0 1 0 0, corresponding to that it's 0, so 0 1 0 0 0. But for the next one, when it becomes 0 1 0 1, so 0 1 0 1, that's equal to 1. So I kept it over here, right? The same way you can check that, right? And you can make rest of the places, by the way, that we as a designer will make sure that those entries will never happen. Okay, that is our role as a designer. This is one thing. And in this case, to solve it, we are going to keep them as don't care. If you are keeping don't care, then life is easy. You can make the boxes of 4 very easily, right? So let's make the boxes of 4 and find out. So this is one box, or maybe, so I need to use only 3 only, right? There is no other way. It's fine. These 3 are only possible, so you can write down each one of them. I am not solving it. So you can have the DA value. Same way you need to find out. Let's find out, okay, so that I can tell you how to make the circuit. So DA, what is the value of DA here? So BC, it's B, right, here, and it's BX or AC bar, then AX, right? So this is the equation with us. So we need to make the circuit. It will have 3 flip-flops. I can call DA, DB, DC, and X is input available to me, right? And these are the outputs, right? So B going with ending with X is going to give me ORing with A C bar and AX. And take all of them to OR is going to give me DA. While making this, make sure that you do not forget to keep the clock, right? So same way you need to find out the value of DB and DC. When you are going to run this circuit with the clock, you will see that it's following what you wanted. Okay. So that's how you can have it. I'm not going into design procedure is written, it's same as what I said. You have to remember these table, okay. Sometimes like outer world it's only D flip flop, but just to make you work, all professors, all people will ask about SR, JK and everything. So same question we can solve it with different flip flops, right. So you can write down the second question, same question you need to solve with all the flip flop SR, JK, D and T. Same question solve with all the flip flops. Okay, that's the second question. Okay, both the questions will be in your assignment. Okay, and same question will be there in your exam also assignment.